Hi everybody, welcome back to my channel. Today we will be evaluating this integral right here using some results that we've gotten from previous videos. Let's see, how are we going to start this? Well, let's create a function of t that's equal to the integral from 0 to 1 of x to the t over x minus 1 dx. And the reason I want to do that is because that's pretty much, we can't really reparameterize that directly, so we're going to have to find some way to get an ln x when you take a derivative. And this is how you do it. If you take a derivative with respect to t of x to the t, you will get back that ln x. So let's just note right now that if we take f prime and evaluate it at the point t equals 0, we'll have our original integral. Okay, so let's see, we can't really, we can take the derivative right now directly. We would just get the integral from 0 to 1 of natural log x to the t over x minus 1 dx. But that's no good because that's even more difficult than our original integral to evaluate. So let's use this fact. Let's use the fact that 1 over x minus 1 is equal to, 1 over 1 minus x is equal to this, the sum from n equals 0 to infinity of x to the n. But we would need a negative sign because this is actually negative 1 over 1 minus x. So we'll use this fact right here. All right. So let's rewrite our f of t using this. So that would mean that our f of t is equal to the integral from 0 to 1 of, let's see, we're still going to have the x to the t, but then it's going to be times the sum, well, that's actually going to be times negative the sum of, as n goes from 0 to infinity of x to the n. And then, of course, we have the dx. And we're going to use Fubini's theorem on this because there won't be any problems with convergence. So we'll just have f of t being equal to, let's see, I want this sum out front. So that's the sum from n equals 0 to infinity. Of course, we have the negative sign. And then, let's see, we're going to keep, we're going to keep this x to the n, and then the integral from 0 to 1 of, no, wrong. It's going to be x to the n plus t dx, right? Because we just switch these around and then combine these. So we have the sum, negative sum from n equals 0 to infinity of the integral from 0 to 1 of x to the n plus t dx. So that will evaluate this right here. That's going to be, let's see, x to the n plus t plus 1 over n plus t plus 1 evaluated from 1 to 0. So that's just going to be 1 over n plus t plus 1. 1 over n plus t plus 1. We don't need the dx anymore. So there we go. That's a legit expression for f of t. Let's see. So now we can get f prime of t from this. So that would mean that f prime of t is equal to, let's see, that's still going to be negative. N equals 0 to infinity of, let's see, well this is n plus t plus 1 to the negative 1, so we get a negative, and this will become negative 2. So, taking the derivative of this will give us a negative sign. So that will cancel this negative sign. And then we just have 1 over n plus t plus 1. All right, so there is our f prime of t. Now, all we need to do is plug in 0 to that, and we have I. So what would that give us? That would give us I is equal to the sum from n equals 0 to infinity of, oh, I'm sorry, this is actually squared right here. Remember, that's actually squared. So this is going to be 1 over n plus 1 squared. Let's do a little re-indexing to, let's do a little re-indexing on this by taking 1 away from this n plus 1 and making that an n squared, and then all we have to do is add 1 to the index here. So this is just going to be n squared, and this 0 will become a 1. That looks like a negative sign, but it is not. Okay, and that is a result that I have derived previously. This is simply pi squared over 6. And there you go. There's the integral from 0 to 1 of the natural log of x over x minus 1 dx. It's equal to pi squared over 6. Hope you enjoyed.